Okay, so we're back. We just finished number 7 here. Let's take a look at these last two examples on the front. Number 8, 2 to the 6th divided by 2 to the 6th. Well, two ways to do this. Method number 1, we could figure out what 2 to the 6th is equal to. 2 times 2 times 2 times 2 times 2 times 2. You would get 64 divided by 64. Anything divided by itself is just 1. So the answer is 1. But the other way to do this is you could say when you divide and the bases are the same, you keep the base and you subtract the exponents. And you get 2 to the 0, which is also equal to 1. Okay, and that's what's giving us this rule here at the bottom. A to the 0 is equal to 1. Anything raised to the 0 power is always going to give you a value of 1. So the last one, number 9, same thing. X to the 3rd divided by x to the 3rd. Keep the base, subtract the exponents, you get x to the 0. Anything to the 0 is always equal to 1. Now very quickly, let me also show you how rule number 3, why does that actually work? Well, let's use an example and we're going to look for this pattern here. If I say 2 raised to the 3rd power, it's 2 times 2 times 2, which is 8. 2 raised to the 2nd power, 2 squared is equal to 4. 2 to the 1st is equal to 2. 2 to the 0, we already know is equal to 1. Now notice the pattern here. If I go from 8 to 4 to 2 to 1, each time I divide by 2. Each time I divide by 2. So every time my exponent decreases by 1, I have to divide my value here by 2. So if I keep going here, 2 to the negative 1, well, I have to divide this by 2, and I get 1/2, which is 1 over 2 to the positive 1. So I divide by 2, and I get 1/2. Let's do it one more time. Okay, now I'm running out of space here, so I'm going to come over here. 2 raised to the negative 2, I take 1/2 divided by 2, and I get 1 over 4. Well, 1 over 4 is the same thing as 1 over 2 to the 2nd. So 2 to the negative 2 is the same as 1 over 2 to the 2nd. Now, if you don't believe me on this, you can take your calculator and we can type 2 raised to the negative 1. 0.5, which as a fraction is 1/2. 2 raised to the negative 2. 0.25, math, enter, enter, and that's 1 over 4. Okay, so this is always going to work. This rule is true. So let's go on to the back here and let's do some more examples. Now a lot of these are going to be very quick. Number 10, 32 raised to the 0. Anything raised to the 0 is just 1. Your answer is 1. Number 11, you're taking this whole thing in parentheses raised to the 0. So it's equal to 1. Now number 12, you got to be careful here. You have 2 to the 0, which is 1. Then you have x to the 3rd. That doesn't change. Then you have this parentheses raised to the 0. Now this whole thing to the 0 is just 1. So you have 1 x cubed times 1, which is just x to the 3rd. That's it. All right, now number 13. Let's deal with some negative exponents. 5 raised to the negative 2. That's the same thing as 1 over 5 to the positive 2. And we can do one more thing here. 5 squared is 25. So the answer is 1 over 25. A to the negative 4 is 1 over a to the positive 4. That's the rule. Now in 15, okay, x to the negative 2 divided by y to the negative 3. Here's what we're going to do. If you have a negative exponent in the numerator, we're going to take this expression down to the denominator. If you have a negative exponent in the denominator, we're going to bring this up to the numerator. So what happens here, y to the negative 3 will come up, and it becomes y to the positive 3. X to the negative 2 will come down, and that becomes x to the positive 2. That is simplified. Okay? That's your answer right there. When you have positive exponents, you're done. Let's look at 16. Now there are several ways that you can do this, but here's the way that I like to think about it. When you divide variables, what do you do with the exponents? You subtract them. So I'm going to do x to the negative 2 divide by x to the negative 5. So I keep the base, I subtract my exponents. Now that's negative 2 minus negative 5. Notice that I had to do, I'm subtracting a negative. So it's minus minus. And then this is y, 3 minus negative 2. I subtract, I do the top minus the bottom. So minus a minus, I'm going to change those both to pluses, plus plus. So negative 2 plus 5, we get x to the third. 3 minus negative 2, that's plus plus. 3 plus 2 is 5. So we get x to the third, y to the fifth. It's good. All right, number 17. So we have a, b, and c. Okay, let's go ahead and divide. Divide variables. Keep the base, subtract the exponents. A to the 4 minus 3. B, that's 6 minus a negative 3. That's minus a minus. Now for c, that's negative 2. Uh-oh, there's no exponent here. So what is that? It's automatically a 1. We put a 1 in there. So it's negative 2 minus 1. So we get a to the 1. And I'm just going to leave that as a. We get b, minus a minus is plus. 6 plus 3 is 9. Negative 2 minus 1, we get c to the negative 3. All right, now this is not done yet, because you still have this negative exponent. So what are we going to do? We're going to take that expression, we're going to bring it down. And our final answer is a, b to the 9th over c to the positive 3. When you bring this down, it changes to a positive. a, b to the 9th over c to the 3rd. All right, let's look at 18 here. All right, there's a lot of stuff going on. Before you do division, you've got to take care of parentheses. It's like order of operations. You got to do parentheses, exponents, then you multiply and divide. All right, so let's see here. 2a to the negative 5, b to the negative 4 raised to the 3rd. Let me zoom in a little bit. When you have all of this in parentheses raised to a power, to an exponent, you got to multiply the exponents. So this becomes 2 raised to the 1 times 3. 2 to the 3rd. That's a raised to the negative 5 times 3 is negative 15. And then negative 4 times 3 is b to the negative 12. Over. This becomes 6 to the 1 times 2. That's 6 to the 2nd. And that's a to the 3 times 2. That's a to the 6th. And then that's b to the negative 6 times 2, b to the negative 12. Now let's go ahead and simplify the integers. 2 to the 3rd is 2 times 2 times 2, so that's 8. A to the negative 15, b to the negative 12, over. 6 squared is 6 times 6. It's not 12, 36. A to the 6th, b to the negative 12. Now the last thing here is we're going to divide. Now we can finally divide. 8 divided by 36. Let's just simplify that. Let's reduce that fraction. So think to yourself, what goes into 8 and 36? 2 does, but actually so does 4. We want the bigger number. So we're going to divide by 4. 8 divided by 4 is 2. 36 divided by 4 is 9. So we're going to get 2/9. When you divide the variables, keep the base. Subtract the exponents. -15 subtract 6. And then for the b's, that's -12 subtract -12. So we get 2/9. A to the -21. B, now look at what happens here. -12 plus, -12 plus 12 is 0. So that's b to the 0. Well, anything to the 0 is just 1. So that's gone right there. Because that's 2/9 times 1 is just 2/9. The last thing here, this a to the -21, this goes with the numerator. The problem is it's a negative exponent. So what do? Let's take it down to the bottom, and we get up top you have a 2, and then in the denominator you have 9a to the +21. Now that's a tough problem right there, but everything is step by step. Now we'll do a couple more examples here. The last rule is rule number 4, power of a quotient. If you have a fraction in parentheses raised to a power, what you do is you take each part of the fraction gets raised to the exponent. So that's a to the m, b to the m, because you do exponent power times a power. So the m multiplies both of these. Okay? So number 19, this becomes 3 to the 3rd over 10 to the 3rd. And then we can do 3 to the 3rd is 27, 10 to the 3rd is 1,000. Number 20, let me write down the exponent for the y, that's a 1. This 4, that's a power to a power, that's x to the 2 times 4, which is 8. And then this is y to the 1 times 4, which is 4. That's it. You can't divide it. Can't divide it because that's already finished. These are different variables, so you can't do anything with those. Number 21. All right, well that looks, there's a lot going on there. So we're going to do 2 to the 4th. We're going to do x to the 7 times 4 is 28. And then this at the bottom here, that's 3 to the 4th. And then that's y to the 8th. So we get 2 to the 4th is 16, x to the 28th, over 3 to the 4th is 81, y to the 8th. And then the last one we'll do here, let's take a look at 22. This whole thing is raised to the -3. Now you know that with a negative exponent at the end, we're probably going to have to flip these things. But let's do this. We're going to distribute the exponent -3. So we get x to the -3, y to the -3, over 2 to the -3, and then z, you got to multiply, that's z to the -6. Now we're going to do a lot of moving here. X to the -3 is going to come down, y to the -3 is going to come down. Z to the 2 to the -3 is going to come up, z to the -6 is going to come up. So we get, up top we get 2 to the 3rd, z to the 6th, and in the bottom we have x to the 3rd, y to the 3rd. And so that gives us 2 to the 3rd, 8, z to the 6th, over x to the 3rd, y to the 3rd. And we will stop there.